Robot and his dad are wandering in the garden to complete the school project of Robot. In the school project, Robot needs to calculate the height of different types of trees with different lifespans. Firstly, he started measuring the length of fast growing trees. It means that trees with a continuous growth reach a maximum height of h meters. The tree does not happen to grow in arm intervals. After measuring them, he and his dad started measuring other type of trees which grow after a certain period. Robert was unable to find its exact length according to the project. His dad said to him that take the help of a calculus. Then Robert asked his dad, what do you mean by calculus? In calculus, something continuous has the same meaning as discussed in the context of the growth of a plant. Now, shifting the focus to the physical intuition behind continuous function and how we could translate this intuitive concept into the language of maths, especially that of functions. The graphs here can help a great deal in developing a clear understanding of the continuous function. Now, let me ask you a question. What is the difference between a continuous and graph and a discontinuous graph? As it is obvious, a continuous graph does not have any breaks. If you want to say in a layman's language, a discontinuous graph cannot be drawn without lifting the tip of your pencil. If you want to draw a discontinuous line, you will have to take the tip of your pencil up. Only a continuous graph we can able to draw by a single line. To understand the idea of continuity a little bit in detail, what we will do now, we will take a few graphs which you are already aware of. Y equal to mod x and y equal to greatest integer function. Let's see whether our check of lifting the pencil is valid here or not. In other words, are these functions continuous or discontinuous? First, let's see the case of y equal to mod x. It's a very interesting function, you know. It has got sharp edges. In this case, can you draw it without lifting your pencil? Again, you can, right? Whether it is sharp or blunt, that's not a problem for me. I can draw it without lifting a pencil. Again, a case of continuous function. Now, let's come to another interesting function y equal to greatest integer of x. Is it possible to draw this graph without lifting your pencil? You can see there are a lot of discontinuities. There are a lot of points where the graph just disappears at one point in and appears at some other point quite as I did. So, is it possible to draw it without lifting my pencil? It is not. This is a classic example of a discontinuous function. You can see there are discontinuities. These points where the graph is actually disappearing and appearing again are called points of discontinuity. So, points of discontinuity will only exist in a discontinuous graph. So, that is the layman's way of understanding it. And a layman's way of understanding is the test. This will be one of the shortcuts we're using to find a function that is continuous or not. The graphical way of doing it is something different. But of course, this is not the classical way or mathematical way to do it. That we will see next. But before we go to that point, I want you to have this point deeply written in your mind. A continuous function is a function that can be drawn without lifting the tip of your pencil, while a discontinuous function can never be drawn without lifting the tip of your pencil. Mathematically, continuity is defined like this. A function f of x is said to be continuous at a point x is equal to a if limit x tends to a f of x exists. This is valued equal to f of a. Understood? So, two conditions for continuity are condition number one, for the function f of x, limit should exist at the point x is equal to a where you are trying to understand the continuity. Second, Not only should the limit exist, but the value of the function at this point should also be equal to that limit value. So, mathematically, if I write it, it will be written something like this. Limit extends to a, f of x is equal to f of a. Continuity of a function is always evaluated at a point. Now, let us understand it a little bit deeper by taking an example. Let's take the example of a simple function y equal to x. So your function itself is y equal to x. I'm putting a question to you. Can you tell me whether this function is continuous at point x is equal to y? So how do you do that? There are two steps in it. We need to find the limit of this function at s is equal to 1. Second, to find the value of the function at x is equal to 1. So let's do step number 1, which is the limit. So limit extends to 1, f of x, which is nothing but limit extends to 1, x, which is your function, which is equal to 1. Now you know how to substitute and get the answer and find the limit because a function is quite straightforward. What if you're given a function 0 by 0, infinity by 0, etc., then you would have to do the left hand limit and right hand limit and then provide that they are equal and then derive the limit value, right? Now, step number 2 is to find the value of the function at this point x is equal to 1. When x is equal to 1, f of x, that is your f of 1, will be equal to, substitute the value we get, the value of the function will be equal to 1. So, the function is continuous at x is equal to 1. Now, let's discuss some algebra of continuous functions which is stated in form of theorems. Theorem number 1. Assume f and g be two real functions continuous at a real number a, then f plus g, f minus g, product of two functions, that is f into g, and they are continuous at x is equal to a. Then f plus g, f minus g, product of two number f into g, provided g of x not equal to 0 is continuous at x is equal to a. Now, let's discuss theorem number 2. Assume f and g are real functions such that f of g is defined as x is equal to a. When g is continuous at x is equal to a and f is continuous at g of a, then the composite function f of g is continuous at x is equal to a. Now, let's use the above theorems in a problem. Prove the function represented by f of x is equal to sin x square is a continuous function. How do you find? We have to observe that the function is represented for every real number. The function f is a composition of g of h of the two functions g and h. What is g? Your g of x will be sin x and h of x will be x square. As both g of x and h of x are continuous function, theorem 2 we can deduce that f of x is a continuous function. Now, you have learned about continuity. Can you solve the graph of the function containing breaks and chunks? Let's find out in the coming video. Now, let's wind up the section through a summary.
Manorama Horizon. Learning made simple.